Hello, everyone. Welcome to our October event. Who has come to one of the OSS for AI events before? Raise your hand. Only a few of you? Great. Well, that means we have more new people. Hopefully you guys all come back. I met a few people today who were like, oh, I was here like a few months ago. So I'm like, great. Hopefully you guys come back. Not, you don't have to come back month after month, but that would be great too. Thanks all for coming. There's going to be a lot of different talks today. We've got 4 different talks today. And there's also the demos out back. Who has had a chance to check out the demos? A lot of you guys have already seen the demos. Some of you guys haven't seen the demos. This group over here hasn't seen the demos. You guys can go check them out afterwards at 7:30. We've got a lot of great presentations. And we also have some housekeeping to go through. So I did not loop this. So this has been just playing this QR code this entire time. Has everybody had a chance to scan this QR code, though? All right. If you haven't had a chance to scan this QR code, this is your chance now. There's a hackathon happening later this month where there are $30,000 in prizes and an Apple Vision Pro. We're partnering with Confluent, AWS, and MongoDB for this. So, scan this, sign up. If you can hack on something that uses real-time data and builds an AI product, you can win $10,000 and also an Apple Vision Pro. All right, it looks like everybody who wants to scan this has scanned this. I see no phones out. Other things that are important. OK, this one. So if you are looking to move into DevRel, I know a company that's hiring for DevRel and SF, and they're going to be giving a talk. John's right over there, so he'll talk to you more about Arize. Their LLM evals. Anyway, he'll talk to you more. He knows way more than I do. So if you want to scan this, if you're interested in doing DevRel, I'm going to leave this up for a few seconds while I kind of just talk into the mic and kill time. All right, everyone who's wanted to scan this has scanned this. That's good. This is the most important slide, so make sure you scan this one. Find me on LinkedIn. I'm now at 9,327 followers. I'm trying to get to 100,000 by the end of the year, so help me make up that missing 90,000. Tell your friends, just start sending my profile to people. Just be like, hey, you know this guy? Just go give him a follow on LinkedIn. I want to become an Instagram influencer. Oh, sorry, LinkedIn influencer. I think all of you guys found this through Luma, right? Did anyone find this through anything other than Luma? LinkedIn. You found it on LinkedIn. Oh, see, that's exactly what I'm talking about. That's why it's useful to post shit on LinkedIn. But you still probably are subscribed to LinkedIn. OK, this is for hackathons. I left this in here. OK, who here lives in SF? Who here is just here for SF Tech Week? All right, so those of you who live here in SF, this one's for you. We've got another event coming November 4th. Those of you who are here for SF Tech Week but make it a point to come to SF specifically for my events, this is also for you. We've got another event on November 4th, and I hope that I'll see you guys there. I've used the same picture since like May, so I should probably replace this at some point. But anyway, if you want to be in the picture, let me know, and I'll take a picture of you and put it here. All right, a few more people scanning QR codes. That's good, that's good. Yes, sign up. OK, and then the last one, this is the hackathon, so you guys have already seen this. So, all right, so I'm going to stop talking. I'm going to let the main events of the night talk. So first, we've got Shuveb. There you are. OK, we've got Shuveb, who's going to come talk to us about real-world data prep for LLMs.
Does Linux support USB-C? We'll find out now. It does. OK. Whoa. Settings. me try that again. Yeah, just trying to see if I can unify these displays somehow. Okay, I guess I'll have to drag and. No. Where? Oh, this one? No. I don't think so. Oops. Oh, crap. Okay. Oh, shoot. Yeah. Okay. No, no, no. I think the resolution was pretty bad. Okay, let me do one thing. Let me see if I can. Okay. I should be able to take this window. Okay. Okay. There you go. Good evening. Thank you for coming today. I'm Shuveb, one of the co-founders of Unstract. I'll be talking to you about how to prepare data for consumption by large language models. Before that, really quickly, right? So we have we're open source. We have about 1,000 plus users. Paid customers process about 7 million pages a month or so, and this is growing really quickly. So that's about us. We are a fully distributed team. We have about 35 folks in the organization, right? So really quickly, PDF challenges. There are many. Usually, when you have to deal with PDFs, you don't get like straight PDFs. The PDFs are super complicated documents, and it's also made complicated by the fact that the software that creates the PDF can make things really hard for you, right? You can have tables, you can have PDF forms, scanned documents, documents that are scanned really well using a flatbed scanner, documents that are scanned like with like a smartphone photo, handwritten scan forms, all sorts of problems, right? So the thing is that when you have to deal with PDFs in the real world, you can't really expect clean PDFs to be dealing with clean PDFs all the time. So you will have PDFs that are, really super complex to deal with. That, that's how it is, right, in the real world, right? And when your PDF processing fails, that means businesses have to resort to manual processing, which is expensive, slow, and not to mention very error prone, right? So why is PDF parsing so hard? So I'll rush through this section because I really want to spend time on the code more than anything else today. So first is that PDFs are designed for fixed layouts, right? But unfortunately, PDFs are a very common document type when it comes to data processing by large language models, right? Any business, PDFs are really the standard, right? So you do have other document types, but the PDFs are super common, right? Scan PDFs are, for example, this is a common kind of a screenshot where I'll be using LibreOffice or some software thereof to show you the structure of the internal PDF. In this particular case, although the document is a PDF, if you look at the right side panel, you can see that the page contains quite literally just one image, right? There's no other component in there, right? So you could have other problems like lighting conditions, rotation, skew, obstruction with the finger, things like that, and compression artifacts are also fairly common, right? Now, many PDFs, they look like scanned PDFs, but you will be able to select text sometimes. That is because PDFs do come with internal OCR systems, but then the quality of this internal OCR can differ quite a bit. So In this particular example, you have this heading called learning algorithms, but then when you look at the text that is OCR'd on top of it, there is double spacing in there. So if you literally search for learning algorithms, you won't find the text. This is a very common problem that you'll see with PDFs, right? The quality of the internal OCR can differ quite a bit between some of these systems, right? So searching versus extracting text is a huge challenge, right? Now, tables are another very common system that common component that you'll need to extract from PDFs, right? And then you'll have, there's a lot of libraries that say that, hey, we are able to extract tables for you. We'll see some examples of that in some code. But then again, Camelot, Tabula, PDF Plumber, these are some very common open source libraries that you have that help you, extract tables from PDFs, right? Now, some of these systems are rules-based. Some of them use computer vision and all kinds of system machine learning. Some folks use hybrid approaches, but then your mileage may vary, and you'll have to figure out how good an extraction system you need based on the quality of the input for PDFs that you generally get, right? Page orientation is another problem, especially for scanned PDFs. This can be pretty challenging because not all OCR systems are equipped to deal with orientation changes, right? Now, another common problem is that you will find text, but then if you go inspect the PDF, you'll find that every character has been basically drawn as a shape, right? Which basically you can't get the ASCII value of it. So it's very difficult to process that way, right? So that's where if you look at the inspection, right? So the A here, or in fact, every letter there is rendered as just a bunch of Bezier curves, right? So that's another headache that you see. Then when you pull out data from a multi-column layout, you'll have to semantically do it. Like for example, in this particular case, when you have a two-column layout, you'll have to go column by column. If you pull out the text across columns, it's not going to make a lot of sense, right? Again, multi-column layouts are important for things like forms, where you will have to preserve the multi-column layout, otherwise it won't make a lot of sense. And then when you have watermarks and such, they tend to confuse OCR systems as well, right? Now, handwritten forms are another challenge that you'll find in the real world. For example, in India, we are dealing with a customer now where insurance agents go fill out hand forms, they come back to the office, and then they'll have to go then process those forms. Super challenging, right? Not all OCR systems actually are capable of understanding handwritten text. So again, you'll have to figure out, depending on your use case, you'll have to figure out what you need to do there, right? Now, PDF elements, for example, just like you can hand-fill PDFs, there are some PDFs that can be electronically filled out. Not all libraries are capable of pulling out information that has been electronically filled out. So we know that, for example, PDF.js can do that, but then that's in the Node.js ecosystem. So if you're usually using Python, then you'll have to maybe run that as a service, then build call that, and then get things done, right? So that is something that you might need to do. And then interpreting checkboxes and radio buttons is also a very common theme in PDF parsing applications, right? So here, for example, citizenship, type of credit, marital status, all those are places where you'll have to interpret the checkbox or radio button, for example, right? Now, these are some of the building blocks that any production-grade PDF parser will need to have. And then depending on the kind of PDFs that you deal with, you may or may not require some of these modules. But then again, anything that's professional needs to have at least these modules in place, at least, right? So this is more of a starting point, really, right? So what we'll do today is that I'll show you, for example, how we can take a bunch of unstructured documents. We will we'll compare and contrast a bunch of open source libraries and common, more popular cloud services that are available to pull data out of PDFs. We'll get the raw text from these services or libraries, and then we'll use Pydantic, a very popular Python library, and also combine that with LangChain just for templatizing prompts. and then we'll convert that data into structured JSON. That's really what we want to ultimately achieve. So in goes a document, out comes clean JSON data, right? That's what we want to achieve, and then we look at different approaches that we can actually go and, right? So very quickly, what we'll do is we look at a table extraction from PDFs. We look at PDF forms that have been electronically filled out. We will look at two type of scans. One scan is a pretty good scan, maybe like done using a flatbed scanner. Then not so decent scans. For example, I just took my smartphone out and I clicked the picture of a form, or I have a driver's license, but the orientation is completely off. Let's look at those examples. Right? Those are, like I said, real-world examples. Finally, we'll also look at handwritten forms, which are also fairly common in the real world, right? So there are some challenges when using large language models to do some work like this, hallucinations and things like that. We're just gonna very conveniently ignore all of those problems and just assume they're not gonna happen. But for the sake of this particular talk, this is more than enough, right? We will look at 6 different libraries and services. We look at PDF Plumber, Camelot, Tabula, Unstructured I/O, Llama Parse, and LLM Whisperer. LLM Whisperer is the service that we work on. We have a technology called layout preservation mode, which I'll show how it really works, right? Now let's look at some PDFs and how they work, right? I'm gonna move over. Oh yeah, it's right there. Okay, so this is an example of a PDF that we will look at. Let me zoom this over. So this is a Apple 10K report, and we are very interested in this particular table, which is on page 14, right? So the challenge with this table is these 2 columns we have called 3-month ended and 6-month ended. And if you look at these columns, they are merged columns, right? So 2 columns are merged here, and the other 2 columns are merged here as well. So, and this is a fairly simple table, number 1. And number 2, this is a native text PDF, right? I'm able to select all the text. This is like as clean as PDFs actually can get. And you'll appreciate that this is actually a fairly simple table, right? I mean, there's not a lot of merged rows, not a lot of merged columns. Fairly simple, but still, I mean, very challenging to process. That you'll see, right? Now, this is a credit card statement, apparently from Larry Page. So this particular statement, what we are interested in is actually grabbing these line items, the actual spends, right? We'll see how we can achieve this, right? Then we will look at a simple form. This is called a 1003 form. It's like a loan application. As you can see, this one has been electronically filled out. So the name of the person, social security number, date of birth, and all that, including the check boxes and all those. These are electronically filled out. I mean, this is a very common application, again, in real-world data, right? Again, this is the same 1003 form, but filled out using handwritten text, right? And the second challenge is that we'll have to interpret check boxes and radio buttons that are, again, checked using hand, right? And then finally, we'll look at an example of a scan which is off orientation, right? And which library is able to handle this, right? The last example is that of a photo of a receipt. Again, a very common problem. So, for example, expense management apps and a lot of these apps actually have to deal with this kind of data, right? So these are some of the examples that we'll deal with, right? Now, coming to the actual code, I'll quickly show you how some of this might work. So, not exactly. Okay. So this is one. Let me try and grab the other. Okay. Yeah, this is okay. Okay. Yeah, this is Camelot. Unfortunately, you're not able to see the headings properly. As you can see, we'll use Camelot here to extract tables. Then this is PDF Plumber. This is Tabula. This is, I think this is Llama Parse, Unstructured.io, and then LLM Whisperer, right? So these are all different libraries we have, and we'll try and extract files from, tables from these particular files, right? Now, I'll have to go back to show you the, to quickly remind you, what we'll do is that we will look at, some of these PDFs, right? So first is we look at the clean PDFs, where we'll have to extract this table and this table, right? And then we look at how we can extract data from these this electronically filled form, the handwritten form, and finally the receipt, right? Now let me go start a terminal here, push it over there. Okay. Hopefully. Okay. All right, so I have a couple of scripts that make it easy so that we can save time. I'll just start this particular script called run OSS. So this should start, you can see at the bottom here that I have Camelot, and then for the two different clean PDFs, right? Now Camelot, for the first PDF, which is the credit card, right? It failed pretty badly because it sees only one table in the whole PDF, right? So not such a great result after all, right? So next is we can look at Camelot 2, which is the Apple 10Q document. It did not find any tables at all, right? So which is really strange because it's really a clean PDF, right? Then when it comes to PDF Plumber, I do see some data here, but it's not very impressive, right? So if you take a look at, for example, this PDF, it hasn't really, it's just found something from here, but then it did not consider this particular table as actual table for some reason, right? So that's pretty bad, right? So let me go to the next, which is actually PDF Plumber did find some information in the Apple 10K report, which is not bad, but then the columns are not maintained. So this is actually pretty useless for us when it comes to processing this data, right? Let's look at Tabula next. Tabula again has found some tables in the first page of the credit card statement, but then again it did not find the table of spends there as well, which is not great for us. Right, so yeah, so and again, this is the Apple statement where we had like a merged column and all that. Again, not a great job. This is actually not very usable when it comes to dealing with this kind of data. So I'm gonna close this out, and now that none of the open source libraries are actually able to deal with even clean PDFs, I'm going to completely ignore them for the rest of the more challenging PDFs. So, we will not deal with open source libraries anymore, right? So next is we look at the same thing with Llama with Unstructured.io. So let's take a look at that and see how it deals with those. Right. So here are the clean versions, the clean PDFs, right? And the other PDFs also you have seen, which are kind of more challenging, the handwritten PDFs and all that, right? So let's move and see how it works there. Okay, so we have some data here, which is the PDF form data, but unfortunately, we don't see any extracted information properly. So if you look at the data from here, the electronically filled out data is completely missing. So I do see some information here, the borrow information, but I actually don't see the if you look at the first name, last name, social security number, I do see some data here, but then AMI America was the data that was filled out. I don't see that here, so I don't think this is going to work as well, right? As for the handwritten text, again, it's not working properly because if you look at the driver's license, it's completely not very legible here, so it hasn't worked there as well. Let's look at the handwritten, the smartphone clicked photo. We have some information, but this is unfortunately not very usable, and then the name of the extracted items are all pretty illegible, right? Although this was a fairly decent photo, right? So this is the problem, when it comes to more challenging PDFs, these are actually failing pretty badly, right? So again, this is the Apple 10K report. This is actually okay. The extraction seems to be pretty decent. But then again, the table structure and all that is not maintained very well, right? So we're gonna again compare this with, let's take a look at how Llama parse, whether it's able to do a decent job. So let's run. Okay. We're starting Llama parse for these files in different terminals. Okay, actually not bad. Let's look at the spend line items. We have a decent conversion to Markdown. So Llama parse, good job. This should work really well for us, right? So let's look at other, yeah. Okay. Why is this? Oops. Come on, B1. Okay, there you go. So this is the table that we got. Unfortunately, the merged column layout isn't really preserved. That is because in Markdown, it's very difficult to, Markdown has no syntax for merged columns. So there we seem to have lost, some data. This is the handwritten form. Again, it hasn't done a great job. So it seems to be working well for clean PDFs, but not so much for the handwritten PDFs in this particular case, right? So let's look at number 4, which is the smartphone captured image. Not bad. It got the receipt pretty well, but then I see 3 items, whereas in the original receipt, there were only 2 items, right? So there's the Jack the Ripper plus fries and then Coke, only 2 items. But for some reason, Llama parse thinks there are 3 items, which is actually wrong if you look at this here. So this is going to confuse the large language model quite a bit, right? Now, as you see, as the complexity of the PDFs increase, we have trouble. And then let me get out of this and finally look at LLM Whisperer, which should give us, we look at what we call as the layout preservation mode. We should look at, give you a good idea about how layout preservation works. Okay, so this is layout preservation mode in action. So it preserves the layout of the original PDF. So if you look at the merged columns, you're able to see that, this is across these 2 columns, and this is across these 2 columns as well, right? Now, this is a very important technology because large language models, it turns out, they're really good with, when the layout is preserved, from the input document to the raw text, right? So we'll see more examples of this. And then we look at B3, B2, okay. Now this is, again, the PDF form. As you can see here, the layout is again preserved. So if you take a look at how, for example, we render checkboxes and radio buttons, you can see that these are interpreted, and you can see literally how you can see the form because of the layout preservation. And if you look at how checkboxes are rendered, right? And turns out large language models are good when you actually do this, right? Okay, this is the receipt. Again, layout is preserved here, as you can see. If you can, the layout is carefully preserved, right? And this is the handwritten text and the driver's license, which was completely off orientation, right? And you can see that, handwritten text, we managed to get everything perfectly out, right? So again, citizenship, this was hand-checked. These are all hand-checked. This is a handwritten text, right? And yeah. So we can take this and then pass it to a large language model and get pretty decent data out, right? So let's do that. We only have like approximately 6 more minutes, so we can probably do that, and then okay. Oops. Oh. Okay. So what we want to do is we want to use LangChain to extract structured data from this particular text, right? So I'm going to bump the text down a little bit. Okay. Okay, so I'm just using 3 different documents from the previous set. Calling LLM Whisperer, it's got the layout preserved text. Then you should see JSON data scroll by. And later on, we'll use the same thing using llama parse. We'll see how, for example, layout preservation works versus how, for example, Markdown works, right? So that's you see the JSON data for the LLM spend, and this is the Apple statement, right? All the code is available on GitHub. I'll pass the links to you, Jan, so you can check out the repos. And from this, we should have clean JSON data back for both the 3 months and the 6 months quarter ending, right? So as you can see. And finally, for the this particular receipt, we have perfect JSON data as well. So we have the vendor name, the purchase date, and this time only 2 line items. So this is, I think this difference is very crucial. So if you look at the original from llama parse, you saw that there were actually 3 items in the markdown, and so the large language model is very likely to return 3 items, not 2, but in the receipt, you had only 2 items, right? So the thing is, if you move the intelligence to the large language model, rather than trying to somehow make the document look like perfect markdown, you'll have better results. That's actually what we have seen, right? So if you try to somehow convert the document into, for example, here, it's as you can see, right? I mean, it did not get it for Europe, Greater China, right? That is the reason is that the large language model is looking at the markdown and trying to figure out what it is, right? Yeah, there you go. So here you have 3 different items, which is wrong. right? So the problem is that when the large language model is looking at a markdown, it's trying to interpret the markdown. But if you preserve the layout, then it's able to figure out that there's only 2 items, not 3, right? So this is a very common problem that, that we see. For example, yeah, let me show you this. So in this particular case, it's taken this as 3 different items. It was actually only 2. So in the JSON output, you actually see 3 different items, right? Which is a problem. And if you go back to this particular table, it did not interpret it for Europe, rest of Asia Pacific, stuff like that, right? So, but if you go back up, yeah, so it's doing a good job with the credit card statements, but then for more complex document types, it's not doing a good job because of the conversion to Markdown, right? So, so I just want to finish. Yeah, I just want to finish with the last few minutes. So, this is the comparison of the different libraries. Unfortunately, the open source ones failed even with the clean text PDFs, and forms and handwritten handwritten text, pretty bad, right? At the same time, Llama parse renders everything as Markdown, right? So it works in some cases, not so much in others. Whereas layout preservation mode does a really good job with many different types of input documents, right? Now, the approach that I want to really harp on is that there are 2 ways in which you can pass input to large language models. One way is that you can attempt to structure the document in a way and then pass it to large language models. Our learning is that don't do that. Rather, you preserve the layout, you let the large language models decide how many rows are there, how many columns are there, and they do a way better job with real-world data. Because like I said, we handle about 7 million pages a month at this point of time for the paid customers. The free customers are a lot more. And then, this is what we have learned, from our work, right? So, yeah, thank you very much. That'll be my talk, yeah.
Okay, we can take 2 questions. Does anyone have any questions they want to ask? Yes, in the back. John.
Hello, how you doing? Ricardo here. I'm a startup founder for an HR tech company, and one of the implementations that we are doing is we're hosting all of our resumes from 350,000 plus users globally on bucket storage in Google Cloud Storage. And one of the solutions that we're working on with Google is pretty much scanning and identifying some of the PII information. And the problem that we have, and that I would like to know if your solution is able to help with, is once they identify that PII information, there's multiple methods that we can rewrite it, right? We can use hash or tokenization or something like that to remove that information. The problem is rewriting that back into a PDF format, right? Is there any way that your solution can connect with something? They have a tool that is called DLP, which is for data loss prevention. Is there any ways that you guys can connect with those tools to be able to rewrite and remove any PII information that gets identified on any of those resumes data?
I see why that can be helpful, but what I don't understand is why do you need to write it back to the PDF? Now, once you have the raw data, there's solutions available in the market that can do 2 things, right? They can either remove PII data, which is like, for example, replacing them with a bunch of X's or Y's or Z's or whatever, or they can anonymize the data by replacing them with a token and then giving you back the data, once, for example, when you need it, right? So these are 2 approaches that people take. But then what I have never seen is that people somehow directly manipulate the source PDFs so that, you somehow replace the PI in there. So the better approach would probably, in my opinion, would be to, once you get the raw data, use a system that can essentially anonymize PII, send that to a large language model, but you will have to trust the raw text extraction system, right? That's the reason why LLM Whisperer are usually available for deployment on-premise as well.
Cool. One more question. Anyone else have any questions? Someone? Okay.
So how are you actually structuring the end output? Is that like a LangChain thing, so it's JSON mode?
Yeah, I didn't have time to cover that. So, I mean, I'll pass on the repos to Eugen here. So there are two repositories available. One is basically just comparing different, libraries and services for raw text extraction. The other repository uses Pydantic and LangChain. So in Pydantic, we define the structure in Python, and then you describe the fields, and then it creates the prompts required automatically to instruct a large language model to take this raw text, but then again structure the JSON data in a manner that you want. It's just Python code, yeah. Pydantic is the library we use, yeah. The code is there. I'm going to share it, yeah.
Cool. Yeah, I'll send it out afterwards.
Thank you so much.
If you have any more questions, you can ask Shuveb afterwards. Next up, we have John Gilhuly from Arize, who's going to be talking to us about LLM observability for agents.
Hello, everybody. All right, hello everybody. How are you guys? Thank you for joining. As Eugen said, my name is John. I'm a developer advocate at Arize. Just curious, who's heard of Arize before or who knows us? Okay, that's a good amount of hands. Okay. For anyone who doesn't know us, I'll do like a quick kind of 2-minute thing and then we'll jump into the agent-specific and evaluating agent-specific side of things for the presentation. So for anyone who doesn't know, with Arize, basically we are a LLM and general ML CV observability tool. So we help you build different AI applications. We do everything from observability, kind of tracing, evaluation, help you with kind of trying different prompts, experimenting with different iterations of your application, and then in production managing things like monitoring, guardrails, a bunch of other stuff like that. So there's a lot that we do in here. One thing I'll call out on this slide is we also have a copilot that we built into our own product. So we actually built an agent into our product as well. And a lot of our learnings around evaluating agents have come partly from that experience and then partly from working with a whole bunch of different clients as they try to set up AI agents around the world. And we work with a lot of different companies as we do this. So with that, I'm kind of curious, before we jump into the agent side of things, who here has actually like built an agent before, just experimenting? Okay, good amount of people. That's awesome. Awesome. So we're going to talk today about a little bit about agents to kind of set the stage and then jump into different evaluation techniques that you can use to evaluate an agent, to improve it, to kind of understand where it's performing well and where it might be performing poorly. To level set, just for anyone who hasn't necessarily built an agent, one of the main kind of patterns that we see when folks are actually going out building AI agents is what you see up on the slide here, where you're using some sort of router, so some kind of initial step to determine where your agent's going to go, some kind of routing or planning step. This can be everything from full LLM with function calling that you're using. It can be just a BERT classifier. It can be a few different other kind of approaches. But basically, that's what takes a user input and then decides what kind of skill or what kind of function or what kind of path is your agent going to go down from there. So you have that kind of initial router step. And then a lot of times you'll have function calls or skills or things like that that accompany your agent here. And so with those will be doing the actual work of your particular agent. So they're actually going through, you might have a full RAG skill, you might have like calls to external APIs or internal APIs or whatever else it might be. But oftentimes you'll have those kinds of steps. And then you might go back to your router, you might just go right to a user with the output, you might kind of go through multiple different analysis steps. Oftentimes you're going back to the router and you're kind of creating that loop where you have that sort of more agentic kind of loop of behavior. I'll mention not every agent uses a router. There's all kinds of different architectures. We could have a whole debate about like what's an agent and when does something become an agent, and we don't necessarily need to go down that loop. This is kind of a common structure that we've seen, and as we think about evaluating, it's a good one to think through. But so just to look at it one more way here, this is kind of a typical flow that we end up seeing with programs where they're going router to a skill and then maybe to some sort of self-reflection step or going back to a user or some other kind of step from there and then continuing to go back to the router and the skills and kind of looping back and forth until they eventually get to a response for a user. All the while, they're also going to be interacting with memory and state and kind of accessing context within each of those different steps to kind of help it along as it moves between those different skills. And so to put a little bit more of a real world example here, say you had a chat bot that you were putting onto an e-commerce site. That bot might use a LLM kind of call initially in the router stage to do its kind of function calling and deciding where it should go down a path. And so in this case, we use like an OpenAI router, and then that classifies the user's initial input into one of a few different skills that it might use. In this case, either like an item search skill, a question answering skill, you might have other ones from there. And then in those skills, you might also have further LLM calls. You might also have calls that are made to models. And that's partly where things get even more difficult to evaluate because you have these nested different non-deterministic inputs and outputs that are coming through your whole pipeline as you go. And so this is kind of a very basic example. You can imagine as you go into production, you get much more complex real-world examples. This is a real agent that is deployed in the wild right now. I won't tell you for what company, but this is one that really does exist. And it's still got that same kind of structure where you have an input, the router function, and then in this case, one of 5 different skills that goes down the path of with all kinds of fun stuff that happens within each of those skills. Everything from LLM calls, API calls, just application code. So all kinds of different stuff. And you can imagine when you're going to evaluate how this performs, it can get really confusing and complex to actually do. So it's a little bit of background on kind of what agents are, just get everybody on the same page for that. I want to spend most of the time we have talking about how you actually evaluate them and why evaluating them is so difficult. And so there's a few things that come up here when you're thinking about why it's so hard to evaluate these. I mentioned the non-deterministic element. That's kind of just a general AI difficulty when you're trying to evaluate the performance of an AI system. The non-deterministic element of LLMs makes it hard to do. Not really specific to agents there, but it is something that comes up and does get kind of compounded in the second case here where a bad response somewhere within your agent's flow can kind of percolate through the rest of your agent to give you even more confusing responses later down the line. Because you imagine you get a bad response or an incorrect response on a step way down your agent's lifecycle. That then goes into multiple other LLM calls and things like that. It just becomes this weird game of telephone where you have the whole sort of output that you get has been mutilated a bunch of different times along that path, which can be fairly frustrating. The other big piece of this is that agents are taking a path that they're determining at the time of execution through their own execution kind of path. So if you have an agent that's executing here, it's making a decision on which route to go down. It might loop back and make other decisions on which route to go down. And so you can end up in cases where agents take really inefficient paths to get to a solution, even though the actual output is right. So if you're looking at the output of an agent, for example, and then you see that the output is correct, you might think that that was a fine run of your agent. But then you actually go into the details and you see that that took 14 loops through your agent's lifecycle to actually get to a solution, and it should have taken 3 or it should have taken 2. So that element of efficiency and how it executes is really hard to understand. And the last one, this is sort of my own take, but I think there's a lot of frameworks that make building an agent really easy to do, especially as you get started with things, and there's a lot of examples that are out there. But it can make debugging harder as you go. So if you're using frameworks that obfuscate some of the what's happening under the hood, that makes things easier to build, but then can make things a little bit more difficult to debug. So as an example of that, this is like a 20-line agent that has multiple different skills that's attached to it. It's super easy to define and to build, but then if you go try to execute that agent, there's a lot that happens behind the scenes. So that one call at the end to invoke our agent is sending it through all these different kind of spans and execution steps that you see. And so if you don't know that that's what's happening behind the scenes, you might get strange responses and not really know why you're getting those strange responses. So that is a bunch of the difficulties of doing it. So how do we actually address those? How do we evaluate agents? We're going to talk a little bit about the how and a little bit about the what. So what pieces of the agent do we evaluate as well? On the how, this is kind of the general flow that we'll go through, and we'll go through each of these steps in a little bit more detail too. But essentially, step 0 is adding observability, so giving you some visibility so you can have stack traces that look like the one on the right over there, so you can actually see what's happening behind your code as you go through and as you build things. So having observability is sort of step 0, because any evaluations you're going to run, or a lot of evaluations you're going to run, are going to be built on all those traces that you capture, all that evaluation, or all that observability data that you've collected about your application. So once you have that, then the step goes from there to basically say the next step that you would go for is to build up a set of test cases that you're going to use to evaluate the performance of your agent over time. These don't have to be thousands and thousands of test cases. Our recommendation is you have try to go as broad as possible to cover the different types of inputs that you might get in your application, but you don't necessarily need 10, 15, 20, 100 different iterations of each of those examples. You can have a set of test cases that's 100 examples, and that covers the types of inputs that you would receive in your agent or you expect to. And you can build up this set of test cases over time as well, too. So this is something that you can kind of create an initial set, and then as you're taking your application out into production or out into testers or whatever it would be from there, as you see new kinds of inputs that you're receiving that you weren't expecting, you can add those to your list of test cases, so you continue to build that up over time. Once you have that, then you're breaking down your agent into individual steps, and we'll talk about like kind of typical steps that we see for that in a second, and breaking them down into kind of individual logic steps and jobs that your agent has to do that you can then evaluate. So then you can create different evaluators for each of those steps using a couple different techniques, and from there, experiment, iterate. What I mean by that last step too is if you have a set of test cases and you have a set of evaluators, you can actually modify your agent, you can swap in new models, new prompts, new code, and then if you keep the evaluators the same and you keep the test cases either the same or growing over time, then you can have more comparable runs of your application, and you can kind of have a sense of surety that you're not breaking something in a different part of your application by making changes to one part of it. All right. So before I go into any pieces, let me actually just pause and see if there's any questions as well too. So this isn't just me talking at you guys for like 25 minutes. Any questions on what we've covered so far? Otherwise, I'll keep going. All right. If there are questions, feel free to just raise your hand as we go too. You guys can interrupt me, whatever it is, as we keep going, because we're covering some ground here. So I mentioned we're going to cover kind of the what as well as the how. To start with the what I mean by that is kind of what pieces of an agent should you evaluate, what kind of individual steps within an agent when you're building an agent should you focus your evaluation on. There are a few that kind of come with traditional LLM evaluation, which is a very funny phrase to say out loud now that I've said that, because traditional LLM evaluation is like 2 years old at this point, max. So the skills and functions evaluation that you see in the middle, that's where you're kind of evaluating individual functions or things within your application that are kind of completing the work. So after your agents decided which step to go to, the actual code that's completing that particular step. So I mentioned before, if we go all the way back actually really quickly to our example here, the skills and functions are kind of these 5 things that you see here. And so there is an element of just evaluating those, making sure that once your agent's made the right decision of which path to go down, that is all functioning correctly. Again, you might have LLM calls within that, so you might be doing things like evaluating the relevancy of responses from your RAG skill that's within your agent or something along those lines. So everything that you do to evaluate normal LLM systems, you can still do to evaluate the agent systems. And that kind of gets grouped under that evaluation of the skills or functions of the agent. So that's the piece that kind of comes with traditional LLM evaluation. The router and the path are kind of the more unique ones to the agent side of things. So with the router, what I mean by that is you're evaluating basically if you're using a router, which again, not every agent does, if you're using a router, you want to evaluate whether or not that is making the right choice of which branch to go down within your whole agent. So if I look at the router, there's kind of 3 jobs that a router would have if you're using a function calling router here. You'd have a job of choosing the right skill, so choosing the right kind of path to go down based on the input from the user. So does it pick the right path? And then what those paths are oftentimes is actual functions that are being called. So there's an element too of does it pull out the right parameters from whatever the input was from the user. If we go back to the kind of chatbot example for an e-commerce brand, the user might say, can you give me the status of my order? The order number is 1234. Your router needs to know to go down the kind of order status path. It also needs to know to pull out that particular text as the order ID and as the right kind of parameter there. So there's an element of choosing the right parameter to pull out of the user's question. And then there's a final step that we talk about sometimes of function generation, which is actually going through, and now that you know the path you want to go down and the actual parameters you're going to extract, generating the right code to go do that. Transparently, that usually works, that step, the actual function generation. If you get the other 2 pieces of this right, the actual function generation part is almost always going to be correct. The parameter extraction is oftentimes the hardest part for some of these models to do if you're using an LLM as a routing system here. So when I talk about evaluating the router, these are kind of some of the things that you would look at to evaluate and to kind of decide on how it's performing. And then the third one of these is the path. So what is the path that your agent takes through, not just choosing the right skill, but how many iterations are you going through? How many loops are you going through? Are you making progress towards a goal with each selection that's made? And are you avoiding steps where an agent might loop infinitely, which can happen? I'll say often, a lot of times there's checks you put in place to prevent that from happening, but there are a lot of cases where agents will loop indefinitely. So these are kind of the three areas that I think about of what are you going to evaluate within the agent: your router, your skills and functions, and then the actual execution path that it goes through. And so with that, let's talk a little bit about, I kind of mentioned the converging piece. Is it making progress towards a goal? Let's talk a little bit about how you actually do some of this evaluation. So now you know what you want to evaluate, what pieces of it. How do you actually run, like what are the techniques for running those evaluations, and what are those techniques for actually measuring that performance? I've got three up here. I'm going to focus on the first two. Happy to talk about data set analysis one-on-one if anyone wants to go into that. I use these groupings to kind of think about the types of evaluations that I might run. There are a lot of types of evaluations, so this is just one way of grouping them together. But I kind of group them into ground truth and then LLM as a judge as two main techniques that we use for evaluation. So with ground truth, if anyone's done any kind of like traditional data science or worked in ML previously or anything like that, this is probably the most familiar to people usually, is the assertion-based or ground truth evals, which is kind of a broad label for cases where you know what the actual expected output for a given input into your model is, or into your agent is. So if you know if you put in what's the status of my order number 1, 2, 3, 4, you know what function it should pick. You know what parameters it should extract. You know what kind of path it should take. And so because you know that, you can then actually calculate things like false positives, false negatives, F1 scores, precision recall, a lot of the stuff that you see on the left side over here, where you're looking at basically, does the expected output and the actual output I got from my agent match? So are those two things connected there? And then you can obviously calculate things like similarity scores or Rouge 1 scores if you're doing more of a soft match of, is the text from my agent roughly the same as the text that I was expecting, for example. So there's a bunch of comparing expected outputs to actual outputs, and then on the sort of far on the right side over there, I think I reversed that correctly. On the right side over there, then you're looking at the comparison of the distribution of outputs to the actual distribution of outputs you got. So I've got an example here of KL divergence. Basically what we're looking at in that case is you might know for a particular application that you've set up that you expect about 10% of the outputs to fall into this car category, you expect 5 to fall into the credit card category, and you can look to see, okay, does the total distribution of the outputs from my model match that? Do I have about 10% in that category? Do I have about 5%? So basically with these, you're comparing either the kind of expected outputs and the actual outputs either at a granular level or at a kind of distribution-wide level in either case. You could do a whole presentation just on these different techniques and a bunch of different ones in here. There's a bunch of ways you can use these kinds of techniques in different versions here. The main idea, though, is that you're comparing a ground truth to what your model spit out. And so there's a bunch of ways you can do that, but that's the main kind of grouping of these. And that works really well when you have a ground truth. If you don't have that ground truth data, it gets a little bit more difficult. And sometimes you might want to evaluate things that don't really work for that sort of setup. You might have more qualitative evaluations that you want to do. Say, for example, if you're trying to evaluate whether or not the RAG skill in your agent hallucinates, then that's a harder thing to write a kind of a ground truth comparison test for. So that's where you might use the other technique we had, which is the LLM as a judge side. Is this familiar to anyone in the room, the LLM as a judge? I see some hands. Cool. I feel like it's the same people who built an agent, so I think we're seeing some kind of commonalities there. For anyone who's not familiar, the way an LLM as a judge works, it's the same idea, or it's, as the name applies here, it is using a separate LLM as a judge to evaluate the output of your application. So typically what you do is you'd pull, say, the input to your application or input to a particular step, you'd pull the output as well, and then you'd construct a new kind of template out of those two and send it over to a separate LLM to evaluate one specific criteria of that. So hallucination is a great example here, where say you've got a RAG skill within your agent that you're doing. You want to pull out the input from the user, the context that was retrieved, and then the response that your skill put out. You're going to send all of those over to a separate model and construct a template, kind of like the one you see down here, where it's saying, is the response based on this context and the query, is there any kind of hallucination present in that response? Or is all of it supported by these two other things? And that works because you're really stripping down and focusing the second LLM on that particular question. Whereas your other kind of LLM call that you made had to do a full generation step and kind of all those pieces there. In this case, you're just telling this other one to look specifically for hallucination, so it's able to kind of focus in on that particular area and assign a either hallucinated or not label to that. This is another kind of showing the same sort of thing in a little bit more detail. I like to pull this one up because it gives you more of a realistic template of what this would actually look like. So in this case, this one's using whether or not the reference text that was pulled is relevant. So it's looking at the query and the reference text, and it's saying determine whether the reference text contains information about whether it can answer the question. So same idea, you're pulling those sorts of information, sending them over to a separate LLM, and then having that separate LLM actually make the call for you. This is really powerful and really helpful, especially if you want to do more qualitative evaluations or you don't have ground truth data to compare against. However, it does come with some caveats, as you can probably imagine. One of them is that if you really want to do this kind of and have any sort of, I say accuracy, but it's really alignment to what a human judge would use, then you kind of have to use the largest models to do this. There's a great paper called Who Judges the Judges that goes through a bunch of kind of detail on this and benchmarks a bunch of different models, but each of these will go through and kind of show that if you use GPT-4 or 4.0, it's going to perform pretty well. If you use smaller models, it gets a little bit more difficult. You can use fine-tuned models, and that's a whole other kind of topic to go down, which is kind of a fun one as well. But generally, you have to use large models, which then also comes with an element of you're incurring additional cost. If you're going to run these kinds of evaluations at scale, you have to kind of have the infrastructure set up to run these particular types of evaluations. So LLM as a judge is great. I think in practice, ideally, folks would use both of these in a production kind of use case. So if we go all the way back here, you can imagine that if you're looking at some of your different evaluations, the router step can work well with a LLM as a judge or ground truth, depending on which approach you want to use. You could have a built-in input and then an expected output for a function choice, or you could use an LLM as a judge. Skills and functions are also going to depend. If it's a RAG system, you might have a combo of both. If it's a external API, you could even go down to like unit tests if it's an external API. So you don't also have to use either of those techniques. There are more traditional software engineering things, especially for the skills section. When it comes to the path is more difficult, and transparently, most of the time with people in production, they are spot checking this a little bit more versus doing really scaled kind of analysis of the path that was taken. Typically, what we'll see a lot of people do is actually just measure the number of iterations or cycles that each query takes through the agent, and then using that to kind of go in and spot check from there. You can use an LLM as a judge and feed in the whole path that was taken and see if that was the optimal path and whether that worked out. It's just very hard to structure that prompt appropriately, and it's very specific to whatever kind of application you're doing. So you can see you kind of use a whole combination of all of these different techniques as you're going about really fully evaluating an agent there. And with that, I want to just kind of do one quick, I've got a little video that shows a little bit of a demo here. It's always kind of fun to see what this looks like in platform. I'll say before I even show this, basically everything I've talked about so far is like conceptual, so nothing that you need to use Phoenix or Arize for, but I'm going to show you guys Phoenix, which is our open source platform, but you could apply all those concepts to whatever kind of framework you want to use. So I will throw that out there as well. So what we're looking at here for this example, I'm going to show you what a couple of the evaluations look like in platform as we run them. This is basically that same chatbot example that we showed earlier. So you can see we're looking at different inputs and outputs. Each line here is a full run through of the agent, and you'll see as we, of course the video is difficult. And you'll see as we click into these, it's going to pull up the full run of the agent, and you can see there's some, we've added some labels here under evaluation for function call and parameter extraction. So 2 of the LLM as a judge kind of evaluations that we ran. And one other thing I'll call out that's really nice here is that you also get, with LLM as a judge, you can instruct it to give you an explanation of why it made that particular choice, why that label was chosen by the second LLM. So that makes it much easier because if you're trying to go, you don't have to go parse through all the different information and find, say, the hallucination or the incorrect function call or why it was incorrect. You can just at a glance see, in this case, okay, the user's question was about promotions for a smartphone, and they made a function call to do a product search as opposed to like a promo search, which was a function we specifically had. So you can see that that's the case where this one's messed up. And I got to stop doing that same button, but so you'll see that those get added in, those explanations there. And those get generated with LM as a judge, which makes it very easier to kind of do any sort of spot checking that you might do. And so you can see it's calling out that piece there. And then I didn't really mention necessarily what to do once you've collected some of the offending cases. So one thing that this is showing here is actually going through and creating a data set out of the examples where you've maybe failed. And then you could take that data set, go use it for further testing if you wanted to. You could run some experiments against that particular data set. So you can see in this case, this is going to show an experiment that was run for that particular data set, where we've basically taken each example in the data set, piped it through your application, and then generated the labels for each evaluation. In this case, we're just looking at the router, so it's that parameter extraction, function generation, and function routing that are going to be calculated for each one. And one nice thing is you can kind of then compare these side by side over time. So as you want to run multiple different iterations of your application, you can look line by line, side by side at the different evaluations that are generated by each of them. Cool. And with that, the last thing I'll kind of leave with here is just I've touched on a couple things that we do within Phoenix and Arize. There's a lot more that I haven't really talked about, so covering everything from more kind of production monitoring, prompt management, and playgrounding, a whole co-pilot agent that I kind of mentioned but we didn't necessarily go into. If anyone hasn't tried us out yet, Phoenix is a great tool. It's open source and 100% free, so feel free to check that out. I'll put up a QR code in a second here as well too. But again, there's a bunch more in here that I haven't necessarily had a chance to talk about. And with that, I'll take some time for questions. Actually, yeah, let me take some time for questions, and then I'll do my last little rigmarole. Any questions on anything we went through here? I'll give you my mic.
Hey, I'm Ty, co-founder and CEO of Copilot Kit, also open source. So great talk, first of all. So you showed us all the evaluations for essentially build time of the agent, right? As you're constructing the prompts, you can figure out if your prompts are good while you're building the agent. Do you guys have any existing or planned extensions for the runtime? So while the agent is running, you can figure out, hey, there's a mistake here, and then surfacing this somehow.
Yeah, definitely. So a lot of those evaluations could also be run at runtime as well too. So once you've got the agent in production, you could kind of, what we usually would recommend is on a regular basis, basically pull out logs from the past X amount of time or a sample of logs and run some of those evaluations there as well too. So you can still use some of those in production. I think there's a couple other tools that we use in production a little bit more. One is actually running any of those evaluations online and sort of as the execution is going. You can do that with certain kinds of evaluations without blocking the execution thread, which can be helpful. And then there's also kind of a subset of that, which is guardrails, which is more like, as opposed to evaluating performance, you're more setting like specific criteria that either need to pass or fail to have a response go through. So this is where you could do things like block any sort of toxicity in responses from your agent. So that'd be attaching like an evaluation to the end of the kind of whole flow there. And you could use similar LLM as a judge or ground truth or whatever kind of other techniques for deciding whether or not something was toxic, but you're using it in a sort of for a different purpose in this case, to block as opposed to kind of measuring performance. But for any of those, we'll show them all on the platform. You'll have kind of rolled up metrics and dashboards and things like that that I didn't really show here. That will kind of measure that rate over time. Yeah. Huh? Yeah, I'm gonna have to answer. Awesome. Any other questions?
Other questions?
All right. Cool.
Okay.
All right, cool. Last thing I'll say, yeah, please star us on GitHub if you are feeling magnanimous. I've also got socks and stickers, so if anyone wants swag for Phoenix stuff, come find me. I will make you star us before I give you swag, but it's a low barrier to entry there. And as Yujan said, we are hiring for both ML engineers and AI engineers as well as dev advocates. So come grab me if you want to talk more about either of those roles. And thank you very much.
All right, thank you very much, John. All right, next up we have Anna, who's going to be talking to us about how you can use AI to create API documentation. And we all know nobody likes writing docs.
Hello, everyone. First, I would love to know how many here are founders. Okay, couple. Have you guys launched on Product 10 recently? No. We launched it today, and Product 10 had a bug, and we were not live for the entire 6 hours. And to make up for that, we are doing a little bit of giveaway. So if you scan the QR code, you will see that throughout the slides. If you upvote us, and if your comment gets the most upvotes, you are gonna get $200 Amazon gift card. So that's for the audience here. Other than shamelessly promoting Product Hunt, let me tell you about what I'm gonna be discussing today. So I'm gonna tell you a little bit of our journey, how we trained our model for the API documentation before ChatGPT was out, and what happened after ChatGPT was released. So what do? We are our API management platform. We do mostly API documentation, but we also do API testing, API changelog, API governance, and things like that. So my background is in engineering. So like any other engineers, I hated writing documentation. Especially English is not my first language, as you can tell. So it was even worse. So I wanted to come up with a solution that would make my life much, much easier. And this was during pandemic, and I thought there could be a better way to automate this. So I started working on Theneo as a side project. Applied to Y Combinator. They asked me to quit my job, which I did. And here I am almost 2 years and something a month later. So let me tell you about why we decided to build our own model. So like I mentioned, one of the biggest aspects was writing the humanly readable documentation, right? It was not just API requests and responses. I didn't want it to have that skeletal documentation. I wanted to have that comprehensive documentation that usually technical writer writes. So back then, there was no ChatGPT. There was GPT-1 and 2 open source versions, but there was no ChatGPT or other APIs that we could leverage. So we started looking into what models we can use it first as a base model, how can we train the model, then to input API specification and output the entire documentation. So first thing that we started with was the base model. So like I mentioned, this was early 2020 or 21, and there were not so many options for open source either. So the things that we were looking at, for example, were T5, BERT, GPT-2, and we were looking at a couple of ways that we would be able to compare all these models. But a couple of things that we needed to take care of before we even started to compare all these models were the data. So this was actually one of the most challenging aspects for us in the beginning, because when we looked at, we didn't have the data, right? So we started looking at what are the open source documentations or API specs that we could find. On GitHub, there are so many open API specs, right? Or Swagger specs, or even Postman collections. So we started looking into those, but turns out every engineer hates writing the descriptions. So all of these specs would not have actual descriptions into it. So we could not really use it. We would have all these API specs, but there was no description, so there was no point using that for training. So, okay, we thought, how can we fix that? So we started hiring technical writers, and we would reach out to these people that had this documentation that didn't have any descriptions, and we tell them, hey, do you want to use Theneo? And by the way, you're going to get for free technical writing services. You don't have to pay anything, but we are going to be using later on for training the model. So this is also one way we got customers in early stage, because no one wants to risk that when you're early stage startup. So that's how they were onboarded in Theneo. So that was one thing. Another was those good quality API documentation that some of the good companies have, like Stripe, Adyen. It turns out a lot of fintech organizations have good quality documentation. So we started also training on some of these golden data set that we called. So okay, we had the data. Then the next thing that came was how do we evaluate and how we structure our model, right? So we first what we did was that we did 70% training, 15% validation, 15% test, which is very standard. And we were working in early days also extremely close with technical writers, where they will be also evaluating manually the output of the documentation. But also something that, let me pull up the screenshot, something that we also did with our customers is that inside the editor where you would run the AI assistant, we would actually pull 3 different descriptions. And it was a little bit annoying for the customers to select which description they wanted to have, but that way we were also analyzing which model would perform the best. And also we would look into, for example, if you selected first description, did you actually publish that description, or did you change it in the production as well? Because sometimes we would see the technical writers would go in, they would change the description slightly more, and there are cases where we would use the data based on what they have changed and retrain the model. But you cannot do that all the time. Why? Because they would input data that is very unique to the company, right? So for example, if Stripe added something that is unique to Stripe, you don't want to use that data. You obviously want to clean your data, so you do not put any customer-specific data. So the next time when I run the AI system, I don't get Stripe's information, but I get a general description. So this was the first version that we had, and we presented this, by the way, at TechCrunch Disrupt. I don't know if you guys have been at TechCrunch Disrupt. It's quite someplace. It was actually, they made fun of it at the, one of the TV shows. And it was exactly, you know what I'm talking about, yeah. It was exactly like that. And we were super excited that we got such a positive feedback. Everyone was excited about what we were building. And it was just, I believe it was 2 months later, ChatGPT was out. So we had really high hopes. We thought we were doing so amazing. And we were saying to investors that, look, the model that we have built, the infrastructure that we build, the data that we have, for our competitors to replicate that, that will be so difficult. And then ChatGPT came out and anyone can use the API. Right, so, but when we're comparing in early stages with ChatGPT, our model was still performing really well because by that time, we already had so many customers and so much data that we were still outputting better quality documentations than ChatGPT. But right now, I would say ChatGPT is quite good. I'm talking about the early stages. So instead of getting too scared about ChatGPT, we decided, okay, how can we also use ChatGPT for different purposes in Theneo? That's where we decided to build AI search in the documentation, and we were the first ones in the industry to do that. So you can basically ask a question, and you will get a response. We have built our own vector database. We do our own calculation, and then we send, based on what the user is asking, a specific information to OpenAI. Another fun fact is that before ChatGPT was out, I don't know if you guys know, OpenAI has a venture company, I guess that's what you would call it, and they reached out and they wanted to invest in Theneo, and we're like, nah, like, I don't know, we were not that excited about it. I don't know why. One of the biggest regrets. And yeah, so what is the value of the proprietary model? By the way, we still keep our model, and there are a couple of reasons behind it. First is we work with lots of enterprise clients, and with the model, it gives us more flexibility, also more flexibility to train based on the use cases that they have as well. And especially when it comes to the enterprise clients, a lot of them cannot even use OpenAI. So it's kind of the limitation. If they were to use, for example, OpenAI for generating the documentation, they would not be able to use Theneo. So that's right now one of the biggest use cases, because as you know, ChatGPT got so good that obviously in so many use cases, it outperforms our model. There are very small use cases where we still perform really well. An example of those are fintech API docs. The reason being is because we have so much data within the fintech organizations. But when it comes to more niche data sets, I would say sometimes ChatGPT will respond much better or give better generalized answers. So let me show it to you exactly how Theneo works in live demo. Can you guys see there with dark mode, or should I do light mode? Dark mode? Okay. Okay, which one? Okay, perfect. Great. So let me go ahead and create a project here. Oops, and I'm kicked out. Let me see. How about now? Is it good? Okay, so I can import my API spec here, or if I need to have other type of documentation, I can have that as well, but most of our automations are for API reference. And by the way, we have more than 12,000 companies that use Theneo, and most of them do use it for API reference. And you can have anything from REST, GraphQL, Async API, SOAP, etc. So let me upload here a sample file that I have. And this is how I can also customize it with AI assistants. If you don't want to use it, and if you want to just import your own markdown content, or if you want us just to maybe add missing descriptions, etc., you can customize that entirely as well. I'm going to select No AI Assistant so we can see how that works in the web editor. And this is also where the AI search comes in. I can make my documentation public. And now my documentation is already completed. I can preview and see how everything looks like before I publish it. So everything that you are seeing here, from the content to the colors, etc., you can fully customize it both in dark and light mode. Not just the colors, but how the documentation has a layout and all these things. And this is how it looks like when I'm going through the APIs itself. I have all my definitions on the left side, and on the right side, I have the request and response. Initially, our inspiration was Stripe, so our first versions looked a lot like Stripe's documentation because we really loved what they had. But we iterated more, so you can have different use cases, and you can customize it based on what you prefer and based on what your users will prefer to use. So let's go back to the editor so we can see how everything looks like. And let me go to one of the sections that doesn't have a description. So by the way, our web editor is a combination of Figma and Notion. The reason why I say Figma is because if you have multiple people, like in Figma, you can collaborate in live version, both on your APIs and on your content. And if you're making changes to your API, you can also export it to OpenAPI spec or combination of Markdown and a spec. So here you'll see that all of my descriptions are empty, and so are the definitions. So let's say here I want to add descriptions. That's when I can also generate AI assistant in the web editor as well. And that's when it will go through the entire spec. It will go through the section description, the header, request body, responses, and I can either select individually what the description should be, or I can just select for the entire section to generate all the descriptions, so I don't have to go through each one of them individually. So, and yeah, if I need to make any changes here, additional properties and all these things, that's how we can do it. And one differentiation as also compared to other platforms is that we do not really have any limitation. So for example, if in the API reference you want to have a content like user guides, if you want to move your API reference or endpoint into a user guide and things like that, you can customize it however you want to. And once I publish it, and obviously here also you have version controls, you also have we do automatically convert all of your requests into multiple programming languages, but if you want to have more sophisticated SDKs, you can either import them, or we partner with different companies like LibLab to pull those SDKs for you. So when it comes to the API testing, this is how it looks like. In real time, I can test out my APIs, and this is designed both for experienced engineers to even non-engineers. The reason why is because when it comes to we've done a lot of research on this, and when it comes to the API adoption, a lot of times it's junior engineers that will start exploring the API for the companies, and they will do presentations even before it goes to the actual implementation. So let me pull the QR code so you can check it out more in details, all the features that we have. I haven't gone through the API changelog and all these things, but let me know what your feedback is. We love honest feedback, so let us know how we can improve the product so we can make the perfect API management tool.
Okay, we have time for 2 questions. 2 questions. Yes.
Oh, hey, thanks for the talk. So are you still using your original model that you just developed a couple of years ago? Are you still using the same model?
Yes. Yeah, I mean, we've been obviously iterating based, now we have so much data. We haven't changed the base model, we just kept iterating on it. Eventually, we might just discontinue based on the enterprises use cases that we will see, or we might just use OpenAI, we will see, because one of the biggest use cases, or one of the biggest concerns for us is the cost, right, with continuously updating the model. So again, we'll just see on how it will go on the enterprise sides.
Okay, so that was my question. Like, why not take all those data and like fine tune on one of these like more modern models, maybe even like smaller ones, because you started with something like pretty, small, and now like small models can like do. But yeah, that was my question. Okay.
Yeah, the biggest use cases when it comes to the model and keeping it for us is the enterprises. When it comes to the cloud version, because enterprises do self-hosting, so they will not even use the cloud version that we have. For the cloud version, that's when we are thinking that we can discontinue and use OpenAI, or allow users to even add their API keys even from other companies like Anthropic, so they can also decide which model they want to use. Initially, last time I was talking about this, also it was a little bit our own ego as well. When you have spent so much, energy on this, you don't want to give up on it in a way. But end of the day, as a founder, I still have to think about the costs.
Time for one more question. Okay, make sure you scan the QR code and go help them out by upvoting them on Product Hunt. Thank you very much, Anna.
Thank you.
All right, next up, we'll have research in video AI from Sushobhan.
Hello, everyone. I am Sushobhan, and I'm a senior researcher at a company called Tavus. So how many of you have heard of Tavus before? Okay, few hands. So yeah, for folks who don't know what Tavus does, it's an API-based digital twin creation. What I mean by that is that you can create a digital avatar version of yourself, and this is not a animated character or like a cartoon version of you. It's like a photorealistic version of you through our APIs, or access them through our APIs. And we have 3 endpoints. The replica creation step, where you give your video of yourself into the to the API, and it kind of takes some time, creates a video AI model of yourself, from which you can then generate video based on either the audio or the text that you provide. And one of the coolest new use cases that we have just released is the conversational video interface. If you haven't checked out, please do check out. And I want to talk a little bit more about the new kind of stuff that we have been doing, and what kind of use cases developers might find for that. But for those who are not familiar with Tavus, let me just give you a brief overview of the products that we have in place, because what I'm going to talk about depends on this. So we support 30+ languages, as I said, photorealistic replicas, and we can generate videos at scale. So once you have created an avatar of yourself, you can create hundreds, even thousands of versions of the same avatar with different text, with different kind of audio. So that's the that's the product. And one of the most successful models that we have had is the Phoenix 2 model. I know Phoenix already means that it's kind of reborn of something, and then Phoenix 2 kind of just is an iteration on top of that. But this model drastically reduces the requirements in that we now only need 2 minutes of video of yourself. It's like a talking version of you looking into the camera, talking like as you would do in a natural Zoom call, let's say. And then give us 3 to 4 hours of time. We process all of that data. We create the AI model for you. And then once that step is done, you can generate new versions of yourself using the inference pipeline. And so that's the Phoenix 2 model. And one of the most like powerful use cases that we have seen is this conversational video interface, where you can really enter a Zoom room. Sometimes you can enter a Zoom room with yourself and have like a realistic conversation. It's like, hey, how you doing? And then they'll tell you back, like, how's their day been? Or we also have the capacity to kind of see as you are like in a Zoom call. So it might comment like, hey, that sofa in the background, that looks really cool. So that kind of, the vision capabilities are also enabled. And this is via an API. So you can just plug and play. You can put it into your own like website, or you can host it, like, try to stream yourself, do all sorts of things. And this is all at 600 millisecond latency. And I don't mean 600 at like just the generation of the avatar, 600 including everything that comes in between. So it's a utterance to utterance latency of 600 millisecond, which I think is one of the fastest, if not the fastest in the industry right now for conversational replicas. So, but that is not the thing that I want to talk today about. But the thing I want to talk about is the instant model. So one of the very like in-demand feature request has been that, hey, all this is good, the resolution-wise looks good, but can we not have to upload these 2 minutes of video to just create the avatar? Or can I not wait for these 3 hours, like these excruciating 3 hours before I can, like, try to like use my avatar? And for the longest time, the answer has been, that's the limitation of the technology so far. But we have heard, and we have been working on this model, which is like, how do we get something like you just upload, let's say, only a 30-second video of yourself, and then we should be able to come back with almost the same quality as our Phoenix 2 avatars, but within a reasonable amount of time, which is like maybe 1x or 2x the time of the length of the video. So if you give us a 30-second video, we should be able to kind of serve you back at like 1 minute time range. And that is a really challenging task. And why do we want to get to this new model is, like I said, reduce the time taken for it to train, reduce the amount of data that you need for it to train. And one of the very big things when you are trying to build a startup out of it is lower the cost, because the cost of running these models, serving these models are, you might know, are huge. And the lower we can bring it, the lower cost we can serve you at, and the lower or better the product grows. So let's talk about how we did it, or what are the key components that needed to fall into place for this to be done. So in any video you take of yourself, there are always 2 elements to it. One is the fixed elements, and what by that I mean, like things like background, lighting, your general face shape, texture, hair, all of these things that don't change meaningfully throughout the entire video. They more or less remain the same. They almost move like a rigid body in some sense. And then there are these dynamic elements of the video, which are more like the exact shape of your mouth, your head pose, the expressions, your blinks, and your wrinkles that form as you smile and all of these things. These are the dynamic elements of a video that changes frame to frame. And the idea that Phoenix worked on was that, hey, if we can really well, if you can learn these fixed elements really well from these 2 minutes of input video, then at inference time, we can just map the dynamic elements based off of the audio, the text that comes in. Now, generating these fixed element components using a neural network like NERF or Gaussian splats and all this has been like challenging because these are really big models and take like hours of GPU training time to kind of get to a good result. What we have been trying to do is, can we do something better than these heavy models and do something lightweight, something more image-based, but also has the elements of 3D in it to kind of do all of this in real time. And also the second was that can we do it with reduced number of frames? And why this is important is because if you have, let's say, 30 seconds of video and if you use all the elements, all the frames of the video, you're already at 1800 frames, depending on the frame rate. And processing 1800 frames at a neural level becomes like you're going to take a long amount, like a huge amount of time anyway. So what we based off our model was that it should be, in theory, be able to work off of just one image at a time. And if you have more images, it should also be able to take that into context, like the extra number of frames into context while generating these fixed element representations. So one of the things that we did was basically create this one-shot representation of the model-based, one-shot 3D representation of the face from a single frame. And then when you have multiple frames, how do you take all of these individual single-shot representations and then merge it into like one single representation? The exact details of how exactly what model architecture we used are kind of proprietary, so I won't be able to kind of disclose all of the secrets here. But some of the coolest applications that we have been able to kind of build, as well as have some of our alpha users test out, is something like this. So here, I think I need, you guys can't hear audio, right? Yeah, that's what I.
Versus like something more German. I think that it comes down to a few things. One is that I'm generally not someone who likes to be in a car that's like way too flashy. And I think being in like a Porsche GT3 both costs a lot of money they don't have, but also is just a more flashy car. I like more understated cars. Of course, the Grand Sport is not that, but it's less flashy than the 911. Yep.
I'm not going to play the entire 2 minutes, but as you can see, this video, you upload a 2-minute video, we are able to kind of get it back to you within 2 to 5 minutes, maybe 10 minutes range. And the quality of this almost matches the Phoenix 2 models, the models that you would get by like training for three hours at ends, and then real-time inference. And one of the other things that we can do is like, yes, the models were designed to work on photorealistic avatars, but you can also kind of.
The art of baking is a delightful.
You can also do it for like animated characters.
Magic is all around us. If only we believe in its wonder. Magic is all around us. If only we believe in its wonder.
So it can also work on like animated characters, and then you can also use something like one of these text to video generation models, Sora-like models. You can use Meta's the latest video gen model as well to kind of create these kind of videos where the person is like kind of moving in a natural way, speaking in a natural way, and then overlay it with the text that you wanted to speak.
The art of baking is a delightful blend of science and creativity. From the perfect rise of a souffle to the flaky layers of a croissant, every pastry tells a story of precision and passion.
So as you can see, like the emotions and all of these, like, the gaze and emotions and like head motions, all of these are generated by the video generation model, something that you might be able to bring your own. And then the shape of the lips and expression and the the face part of it is modulated using our latest instant model. And you can use this for all sorts of applications, and that's why we have built it as an API. Is like we want to empower the developers to kind of find all these applications and figure out like where this fits their needs best. And we kind of are focusing more on like the quality and bringing the latency, bringing the costs, bringing the fidelity of these models and improving over time. And with that, I think I'm open for questions.
Questions?
Hey, so you guys do pretty well for like just the face, for example, but do you guys also generalize for, let's say you have to incorporate motion and other, activity that you can sort of make like a twin for? Is that possible through Phoenix or no?
By activity, do you mean like hand motion and full body kind of stuff? We do have plans to kind of support that, but for now, all our Phoenix 2 models as well as the instant model, they focus only on the face. The idea is that the face is a simpler, in many ways, like a simpler way to model, because it kind of deforms as a solid body, moves around like a rigid body. Whereas your hands, they can take all forms of shapes and which are much harder to kind of model. And for the kind of applications that we are targeting right now, the face kind of almost delivers 80% of the value there. But yes, we do have plans to kind of generalize to at least like upper half of the body and maybe like the full torso at some point in the future.
The value proposition there is... No, you're good. Because then your value proposition there, if you can do the whole body, is you can start doing content generation for content creators, and then you can make multiple different like A/B testing for different types of content that users are looking for. So it looks like I don't know, I don't want to tell you what product to vote, but yeah, I just thought it was a cool idea. Thank you.
Yeah, so that's the coolest thing about it, is like you think of the product, you think of the application and how it can be built, and we kind of are building the API behind it that might power the applications that you're building. So yeah, for full body kind of avatars where you are able to control the hand motion and all of that, you might have to wait a little longer.
Are there any other questions? All right. By the way, if you guys would like to talk to Susho in his... Are you going to be at the event tomorrow?
Yes.
If you would like to talk to Susho in his office tomorrow, there's an event at the Tavus office, and he'll be there, and I will also be there. So
we are having an event at our office tomorrow. If this feels exciting to you, come check us. Come check out our office and talk to a few more folks and see if you can find a application. Yeah.
All right, thank you guys all for coming. That wraps up our talks for the day. So for the rest of the time, you can go back to checking out all the products, all the startups back there that are demoing. Just feel free to talk with each other. There's still some pizza left, so if you're still hungry, please go grab some pizza. Nobody is taking it home, and it goes bad the next day, so please grab the pizza.